Alright, this video continues on with what we started in our chapter 5 about polynomials. We've got one more definition that maybe kind of fits with what we were actually doing in the last video. And then we look at a way that we can model polynomials using algebra tiles. Okay, so first one more definition that we've got to deal with, and that is the degree. Okay, one more E. Degree of a term is the sum of the exponents on the variables in a single term, or a monomial. So we have a monomial here, 3x squared. Okay, monomial. The degree then is the exponents, the sum of the exponents. So in this case, the exponent is this 2. That's the only exponent, which means that this would have a degree of 2. Okay, if we did another one, we could have a 4xy squared. And if we were going to find the degree of that, we would look at and recognize that there's a little 1 that's not written there beside the x, right? And then there's also this 2, which means that the sum of that is 1 plus 2. The degree is equal to 3. Okay, so it gets a little bit more complicated when we look at the degree of a polynomial, then a little more complicated than just the monomial. So the degree of a polynomial is the degree of the highest degree term in the polynomial. So what I mean by that is if we had a polynomial, okay, so 3x squared minus 4y, okay, we would need to determine the degree of each of the two terms. Okay, so the degree of this first one, right, we get from the 2 there, so degree is 2. Okay, degree here, there's a little unwritten 1, so that means the degree is 1. Okay, the overall degree of this entire polynomial is the degree of the term, the highest degree term, which means this one. So the degree of the overall polynomial is 2. Okay, we'll do another one that's maybe a little bit more complicated. Okay, we have 4x plus 3x squared y minus 7x squared y squared. Okay, so we will again find the degree of each of the 3 individual terms. Okay, so the degree of this one is 1, because there's a little 1 there. Okay, the degree of this term is 2 plus 1, so 3. And the degree of this last one is x squared and y squared, so 2 plus 2, degree is 4. Okay, we look at which of these terms has the highest degree. That becomes the degree of the entire polynomial. So this polynomial would have a degree of 4. Okay. Next, we will look at modeling polynomials. Okay, modeling polynomials goes back to using algebra tiles, which you've been introduced to in previous years. I would say that likely you will probably start, many of you will start to see the value of algebra tiles more as we use them in this sense with polynomials than maybe you have in the past. So we'll do a quick review of what they are, and then we'll show a little bit, and we'll get into it more in future videos, but we'll show a little bit the power of these algebra tiles in modeling polynomials. Okay, so quick reminder, positive 1 tile is a little square. Okay, positive is colored in. Okay, and negative negative 1 tile is just a hollow box. Okay, a positive x tile then is a line, and again, because it's positive, we color it in. Okay, the negative one is just the same shape, but it's not colored in. Okay. The positive x squared is the large box. Okay, and again, because it's positive, we color it in. Okay. The negative x squared then is the hollow empty box, same size. Okay, so you'll see those, and you'll start to get a hang of how easy they are to use, and it will make good sense. So we'll do a couple examples here to show how we can use them already. Okay, so firstly, we are going to use them to model simple polynomials. So I will write a polynomial down. We will have 4x minus 3. Okay, so we will draw this out. Okay, so 4x is represented by 4x things, and remember, those are positive 4x, which means that each of them should be colored in. Okay, and minus 3 is the same as 3 negative 1 tiles. Okay, so we will take 3 negative 1 tiles. Okay, and we have modeled out 4x minus 3. Okay, I'm going to do another one and allow you to do it yourself. Okay, so I'll write out a polynomial, and I'd like to check in your notes that you have modeled it yourself. Okay, so 3x squared plus 2x minus 6. Okay, so I'll let you do that one on your own, and I'll check that in class on next day. Okay, then finally we can do the alternative as well. When we show a algebra tile model, okay, you would be able to turn that into an algebraic expression as well. Okay, so if you were, say, given this right here, okay, at that point I would be able to say, well, I have 1x squared, right? I have 2 x's, and I have 3 1's. Now it's important to note which ones are shaded, which ones are not. The x squared is not shaded, which means it's a negative. The x blocks are also not shaded, which means they're negative. The 3 1 tiles are shaded, which means those are positive. So I put this together in an expression: negative x squared minus 2x plus 3 would be my expression that is shown by that algebra tile model. Okay, I'll do one more, and again I will get you to write out the answer to this one on your own. I'll check it in class next time. Okay, so I'll let you do that one on your own as well. Okay, that is modeling algebra tiles. We will use it a lot more in future videos, but hopefully that's a good start for you. Okay, thank you.